Hello class, this is a demonstration of how to draw a Newman projection from a basic chemical structure. Methane is the simplest hydrocarbon and has the chemical formula CH4. It can be drawn like this, with a carbon and 4 hydrogens attached. Now if you take two pieces from your model kit and connect them together, we can have a three-dimensional representation of methane. This piece that I'm holding in the center is our carbon. Each 4 of these bonds coming off are going to our hydrogens. We can extend this hydrocarbon by 1 to give ethane. Ethane has the chemical formula C2H6. Remember, hydrogens only form 1 bond and carbons form 4 bonds. The structural formula of ethane should look like this. In organic chemistry, it is important to think of molecules in 3 dimensions. We can redraw this ethane molecule with a bit of perspective to give a 2-dimensional version of a 3-dimensional molecule. In this illustration, wedges and hashes are introduced. The wedges are coming towards us, and the hashes are going away from us. The normal lines or bonds are within the plane. Another way to illustrate 3 dimensions is by using Newman projections. This is a view directly down a carbon-carbon bond. Looking back at our model, let's connect another piece to methane to form ethane. Our model of ethane should look like this. Now, if we look back at our perspective drawing, here's our carbon-carbon bond, our hydrogens within the plane, the hydrogens coming towards us, and the hydrogens going back. If the model is rotated, we can look down the carbon-carbon bond, which looks like this. We'll be using this view for the rest of the demonstration. So by looking at this view of our molecule, we can draw a Newman projection, which should look like this. This is our front carbon, which can be represented on our drawing by this intersection here. This large circle is our back carbon. The front carbon has 3 hydrogens coming off, 1 going up, 1 left, and 1 right. The back carbon, which we can't see if we look at it in this perspective, is represented by this circle. Attached to this circle are 3 lines with H's for our hydrogens, 1 going up, 1 going to the right, and 1 going to the left. I've circled one of the hydrogens so we can keep track as we rotate through the molecule. On our model, I'm going to connect a white sphere to represent the blue circled hydrogen. When making rotations, keep one of the carbons stationary and rotate the other. We will keep the front carbon stationary. The first rotation is 60 degrees. Now continue holding the model in the same orientation, and then you can redraw it. So here's our 60-degree rotation. Our labeled hydrogen moved from here to here. A redrawing of this Newman projection looks like this. Notice the hydrogens are now angled in between, and our hydrogen that's circled is pointed slightly to the right. We can continue rotating, and we'll rotate 60 degrees every position. So another 60-degree rotation will give us this conformation. Our drawing, which is now at 120 degrees, should look like this. So let's continue rotating. 60 more degrees will give us a representation that looks like this. Our new drawing, which is at 180 degrees, looks like this. Notice our circled hydrogen, where our white sphere is pointed down. So now we just have a few more rotations to go. 60 more degrees will bring us to 240. Notice our labeled hydrogen is going now to the left behind this hydrogen. We just have 2 more rotations to go. If we rotate 60 degrees again, will result in this conformation. The labeled hydrogen is now pointing up and to the left in the back. Notice how the front carbon has remained stationary the entire time. So if we rotate a final 60 degrees, we'll be left with this orientation, which should look familiar because this is the orientation we started with. Here is our drawing at 360 degrees. Once you have mastered ethane, which we just went through, why don't you try propane and butane? Remember, it's not a bad idea to watch this video again and pause at each rotation, try to draw your Newman projection, and press play again and see if it matches what we have in the video. Thank you for watching the demonstration, and good luck with your studies.